the applications. Then the next level of infrastructure as a service, where you'll find some of our big competitors like Amazon Web Services focus on the infrastructure as a service, where essentially you're handed everything above the operating system, and you're allowed to go to town with that as it were. The next level up being where you focus strictly on the application that you want to develop and the corresponding data. And the runtime, clustering OS, load balancing, all of those other sorts of things are managed by the platform underneath. And the Windows Azure platform fits within this space, the application as a service and platform as a service space. And one thing to note is that our infrastructure as a service offerings are actually in preview. So you might say, if I were being frank and pessimistic, that we're late to the game when it comes to infrastructure as a service when you look at our competitor Amazon Web Services. But the reality is that Microsoft has a deep belief in the platform as a service model, where as much as possible is managed by the underlying platform, and you push down on that platform so that the total value of the applications that you build is derived from those applications themselves, as opposed to all of the infrastructure that you have to put together in order to make those work. And then, of course, there's software as a service, which is the result of any of these taxonomies where the end result is software as a service, like Salesforce.com.
So just to clarify where you draw the line in past, would that be like, say, SQL Server instances that are rentable by the hour and scalable or something, or what's the frontier?
Yeah, that's a great question. So there are a number of answers to that, and I'll get more into that a little bit later. But the first most basic platform as a service offering from a SQL Server perspective is something that we call in Windows Azure SQL Database. And that's a multi-tenant service that's managed by way of a resource manager that makes sure that the services provided to each tenant are as fair and as even as possible, and includes things like throttling capabilities and other sorts of fairness measures. Now, when you design for something like that, you have to understand that you're going to have to design for failure, because you're going to have to defend against things like throttling, things like your neighbor eating up all the resources that were otherwise intended to be fairly shared. Now, within the Microsoft stack, you're going to find a number of other possible alternatives to this. And one of those is that you could go and say, for example, use our infrastructure as a service offerings and spin up your own SQL server using infrastructure as a service. And then when you do that, you actually get some amazing capabilities. You get to go back and finely tune the way that you manage your disks. You can go and have, on an extra large instance of a Windows Azure VM, up to 16 data disks that you can RAID, and generally you'd want to just stripe them, given the redundancy that's inherent in Windows Azure storage, to achieve many kinds of performance characteristics. There are others that I can talk about that are forthcoming, and some of those are under NDA only. So if that in between this multi-tenant service and this service that is largely managed yourself on top of infrastructure as a service or of interest, let's talk, because we do have a solution that's coming in the future. Does that help? The next thing I'm going to talk to you about is also something that I think is pretty obvious to folks at your level, which are the economics of the cloud and why people choose cloud infrastructure as opposed to traditional infrastructure. And as you know, when first going to deploy any piece of application infrastructure, you've got this initial upfront IT cost to go and buy some amount of servers and infrastructure to do that. And then over time you start to realize that you're going to exceed the capacity that you have, and you're going to buy another chunk. And at some point along the way you're going to find that you have an undercapacity. And then you're going to do it again. And then you're going to find that you have an overcapacity. And then you're going to go through this constant cycle of fighting the economics of traditional IT. And I've just sort of called out those here in the following transitions. The cloud model is really intended to align your cloud computing investments with your actual load forecast. And there are specific pieces of infrastructure and technology within the cloud computing space that help you to as closely align what you spend with what you need over time. And that includes very much so like this area over on the far right where you see a big drop off, being able to shed resources as you find that your business does no longer need them. And moving on through this slide.
Are you going to talk about the costs? Because I guess I have a question on the previous slide.
Yeah.
About the cost model, because one way to do it is to say, look, it's going to cost you less because we're going to leverage the same hardware investment, for example, across multiple.
Mm-hmm.
Another one is to say, look, it's going to cost you less than over provisioning on premise, and we'll keep the difference. You know, there are different models. Of
I see. I think I understand your question, and let me see if I can start to address that a little bit. Because this deck right here doesn't focus much on pricing, so this is a good way to segue.
What sort of your model, more than specific price points?
Sure. So when you buy Azure, you're always looking at Azure from the perspective of what you're going to use. Always. That never changes.
Right.
Okay, and so in terms of what the margin is, the margins come from the economies of scale that we get by being able to build out data centers that are huge and highly intelligent in terms of self-management and low cost.
Right, but if I needed X capacity, let's say my capacity was stable.
So your capacity was
Is it cheaper
stable.
for me to go to Azure or to do it on premise myself?
That's a very interesting question. And I'm going to say that the answer to that is case specific. And so if you recall, one of my earlier statements was that Microsoft does not believe that it's all public cloud or all on-premise,
Right.
all on-premises, that there is going to be some room for some hybrid scenarios where it's going to make sense. I'll give you an example. I used to work for a semiconductor that you guys might know of called NVIDIA. And while I worked at NVIDIA, we have huge computing resources. And at NVIDIA, the notion of having pure public cloud solutions for a lot of what we do was completely nonsensical for some workloads. For other workloads, it is going to make sense to do either some combination or both. But I will tell you, this is more of an anecdotal data point, because once again, this is something that is case by case specific, that there are companies that we're working with who have an explicit CEO level initiative to get out of the data center business in X number of years, because of the fact that the economies of scale that you can get in the cloud, regardless of the fact that you're steady state generally, or if you're spiky, both make sense. So I guess the answer to your question is that it doesn't only just make sense when you're spiky and variable, but it can also make sense when you have predictable load. And to speak further to that, we have purchasing models when you talk about Windows Azure. And for folks like yourselves, a very common purchasing model would be what we call an enterprise agreement. And in those enterprise agreements, you actually pay an upfront amount for the amount of Azure that you want to buy. So you actually are making a statement to Microsoft, and Microsoft's making a statement back to you that we're going to reserve these resources for you, and we're going to have a financially backed SLA that says this amount of capacity is available for you. Okay? And so those kinds of agreements, those enterprise agreements, comprise the largest spend on the Azure platform. Okay? A little bit more data just about Azure in general. We currently have 8 regions where we have data centers. Those are the purple dots that you see on screen. 4 in the US, 2 that are brand new, the East and the West, 2 in Europe, 2 in Asia. And we're building out many more. When and how, those are details that not even I get to know, but the expansion is aggressive.
So Amazon, within a region, Amazon has a concept of like availability zones, right?
Right. So we're not quite the same. So within an Azure region, that is an availability zone. Their regions are a little bit, they're structured differently than ours. So you could equate an availability zone to a region. That would be the best analog. Okay. But when you start to talk about doing things like geographically distributing your workloads across multiple data centers for disaster recovery or for other sorts of uptime requirements, there is the notion of an availability set that I can talk about at a later stage, which is a construct similar to what we're talking about here. From an application development perspective, I want to make the point really clear that Windows Azure is not the Microsoft developers cloud. I think a lot of people have that notion, maybe you folks don't, but I want to call out specifically that it's a very open platform with support for many different development environments that are natively built out by the Windows Azure team, not just community supported, but first class developed by the Windows Azure development organizations. And they're also made open source and put on GitHub. So in terms of building blocks, what comprises Azure? The Windows Azure platform contains a lot, and I'm not going to be able to, in any one presentation, talk about the extent of what Windows Azure is, but I do want to focus on some core capabilities that are the most commonly used. And those include the compute, data management, and networking capabilities. So first of all, we have this notion in both the platform as a service, or PaaS, and infrastructure as a service, or IaaS, spaces called a cloud service. And a cloud service is a logical container for compute resources, whether they be infrastructure as a service VMs, or if they be platform as a service web or worker roles, which I'll talk to you about in a minute. And these cloud services are the things that, they're the level at which you decide where you geographically want to be positioned when you deploy a cloud service. Next, we have virtual machines, where you can instantly run either existing applications with existing VHD virtual machine files on Azure, assuming that they're appropriately configured, or you can go and build out virtual machines from our gallery, which includes both Windows operating systems and configurations, as well as Linux, and I'll talk more about that in a little bit. We have a very lightweight capability called Windows Azure Websites, and Windows Azure Websites is really intended for high density website deployment, and that I'm gonna guess is not going to be of as much interest to this room, so I'm not going to spend too much time on it. But if you quickly wanted to be able to deploy something like a WordPress or Drupal or Joomla site, you would be able to do so really rapidly, and in many cases at no cost at all. So we have some on-ramps to the system that are extremely compelling. Moving on to Windows Azure Cloud Services. When we talk about cloud services, there are a couple of constructs which are two of the most important. One is called a web role and the other is called a worker role. And you can think of a role, whether it be a web role or a worker role, as being a unit of scalability. And before I talk about what I mean by a unit of scalability, let me differentiate web and worker roles. So a web role is really just a worker role with IIS, or Internet Information Server, pre-configured for you to deploy your IIS-based website on. Okay, that's the fundamental difference and the only thing that you really need to focus on when you think about the difference between those two. But what's a role? A role is the notion of a compute unit that can scale upwards as well as outwards. So you can say that you've got, let's say for example, and let me poll the room. How much open source do we have here versus Microsoft-based solutions? By a show of hands, who prefers the open source stacks? Okay, great. So I'll talk a lot more about the open source side of things. So let's say, for example, you wanted to deploy one of my favorite little HTTP daemons called Nginx, and you wanted to deploy that on Ubuntu. What you could do is you could spin up a worker role, and you could say that I wanted to deploy that as a specific VM instance in my cloud service, and I want it to be this big, this many cores, this much RAM. And in the case of where you're dealing with open source stuff and you want to be able to do things on Linux, you'd be working in our infrastructure as a service space, and you'd say that, let's say I want to have a load balanced Nginx farm that consists of 20 nodes. So you'd go and build all those out. You'd hook them up to the same load balancer that would front all, let's say, 20 instances that you want, and you'd be off to the races. Now let's talk back for a second about web roles and a little bit more traditional platform as a service offering, which could include things like PHP or other workloads that run on Windows. And I know that there is a lot of open source that is running on Windows. You can have a web role that says, I'm going to exist at size X, where X is, let's say, an extra large, 8 cores of RAM, 14 gigs of memory, certain amount of disk, certain amount of I/O guarantees, and you want that thing to scale out horizontally to from 1 to n instances, and you want to do that on the basis of the amount of load on the system, or the timings where you expect to have increased or decreased load on your platform. And the web role becomes that unique thing that scales just in that way. And let's say, for example, that you had a multi-tiered application where you have a front end that gets hammered a lot. And you have an application tier that maybe it gets half that load because you've got good caching in place and you've got other sorts of mechanisms that shelter that highly intelligent application layer from the pounding that the front end gets. Well, you'd want to factor those two things into separate roles so that you could scale them independently. So you could say that, hey, maybe I want really big application instances that are my middle tier, but I only want 5 of those. But maybe I want 20 or 100 of my front ends, and I want those to be smalls.
So a question,
Yeah.
that's typically what we call elasticity. And
Yeah.
I was at a Microsoft event, an Azure event, where the CEO of RightScale was there, and RightScale is well known for, providing kind of an elasticity solution for certain application vendors, so you could, transparently, based on templates, scale up or down in the cloud. So today, to do true elasticity in Azure, do you need a third-party solution like at RightScale, or are there hooks being built into Azure now that allow you to create templates that scale up and down?
Both.
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 Okay.
So if I wanted to make a solution that I had a lot of control over, and I wanted to be able to make that conform to my numerous business requirements that only I understand, what I'd want to do is use something, for example, called the Windows Azure Application Scalability Block, or Wasabi. That's the short name for it. And basically what it is a piece of technology that allows you to do those kinds of scalability changes based on sets of rules that you would set up, as well as on dynamic application-defined triggers. If you want something that is more of a full end solution, look at RightScale. RightScale is a great tool, especially if you're in the open source space and you're working with more infrastructure as a service. I would highly recommend looking at those solutions as viable additions to your cloud offerings. They give you a lot more visibility and dashboard style control over the kinds of things that you'd like to do. And I'll use this point again to point out that the Microsoft Cloud is very open. It's intended to facilitate taking advantage of all of these many different ways of approaching cloud. I've talked about Windows Azure virtual machines, and this is really another slide that's talking about that. And the main thing to note here is that it highlights that in the current state of affairs, we, from a Linux perspective, support CentOS, SUSE, and Ubuntu. The list of distributions that we have native images for, it will be growing all the time, especially as we exit preview. One of the ones that was a sticky point for us, frankly, was Red Hat, and that was much more of a licensing complication. But fortunately, we do have CentOS as a surrogate. Moving on to Windows Azure websites. I mentioned this before, and I'm going to once again go through it very quickly. It's a very lightweight way of deploying websites in an environment that's scalable, but limitedly so. Whereas in something where you had a web role, you could scale to hundreds or thousands of instances. You can scale to 3, right? It's specifically targeted towards the lower end. But it's a great on-ramp to Windows Azure, and it has a very simplified management model. You can do things like deploy from Git, deploy from TFS, and all of that great stuff. Moving on to SQL Database. We talked some about this earlier on. In terms of SQL Database being a multi-tenant database system whereby you actually have 3 copies of your database at any moment in time being managed by the underlying SQL database fabric. And 2 of those instances are written to synchronously, whereas a third is written to asynchronously. And a lot of things happen behind the scenes with the SQL database capabilities that we have in the platform as a service offering. One of which is you get to take advantage of a technology called federations. So a caveat to SQL database is that any one database is limited to 150 gigabytes, which for a lot of people would say, okay, I'm going to throw up my hands, that's completely useless to me. My databases are terabytes in size. Well, the way that SQL database works is that it has a built-in managed sharding capability. And that sharding capability allows you to horizontally partition your data based on keys that you would define in the database and on specific tables that you know are going to grow beyond certain acceptable bounds. And it's something where you could roll your own sharding capability, but there are numerous advantages to the fact that you've got a pre-built managed sharding capability within SQL database. It could be said that if your database is 150 gigabytes, maybe you'd be better off with 151 gigabyte databases. And part of the reason for that is that the system is multi-tenant. And so the multi-tenant nature of SQL database means that you get more performance as you have more databases. So if you're able to spread your application across more and more databases, the more performance you're going to have all the way through. Some caveats on SQL database that I think I've mentioned before. There are throttling events that occur where you could, for example, let's say somebody who's sharing your instance slams it. You're going to get an error code back that says you've been throttled, and you've been throttled because somebody else took up too much resources. And you'll be told specifically why you were throttled. There are other scenarios where maybe you did it yourself, and the engine will tell you that as well. Coming in the not too distant future are managed SQL databases that have resource reservation capabilities, and that's something that I can only mention at a high level, given that it's NDA level information right now. But SQL database is definitely a powerful technology with a lot of potential if it's used properly.
When you talk about,
Yeah.
sorry.
Go ahead.
On databases, do you support bring your own as far as licensing goes?
Yes. Yes, if you, for example, have a SQL Server license of your
No,
own,
no, 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 not SQL Server.
like Oracle, or
Let's say Oracle, MySQL, or
Yes.
Postgres, or whatever.
yes. I mean, in short, the answer is yes. License portability has been a big issue for all of our folks that have been doing migrations from one site to the next. When you're talking about SQL database, it doesn't really apply because you're talking about a managed service as opposed to SQL Server as an entity. But what's interesting about SQL Server, and we'll see where this goes with other database engines, but SQL Server is actually licensed two ways. One, you can bring your own license, or you can pay a little extra per hour and get SQL Server licensed that way. And that's incredibly compelling when you consider the high cost of a single CPU license for SQL Server.
If you order to bring, say, Oracle or DB2, that would be on the infrastructure as a service.
Right.
Yeah.
And then the licensing is largely between you and the vendor at that point, right?
Yeah.
There isn't a terrible amount of magic beyond that.
So Sean, without going into like a 15-minute conversation about pricing,
Sure.
I'm curious because Microsoft has this relatively unusual position in this collection of markets
Okay.
as a creator of system software and application software and infrastructure software and so forth, and also then providing this as a service. Is the general approach of Microsoft for pricing to, take the bring your own license model versus the pass model for SQL Server? Is the general pricing model to price it a little above bring your own license because you're providing the service of all the maintenance and making everything work and the updates, or is it to price it a little below that because you have the economies of scale and the software was incrementally free to you anyway?
That is a wonderful question that I could only answer on a case-specific scenario because you're talking about apples and oranges, unfortunately. The management is very different. What the services provide is very different. But is there strategically a desire for you to use one or the other based on price point? Not so much. You're not going to
What
find
I'm
it so
thinking is
much.
it's compelling to me to hear, as Microsoft, we have economies of scale and we can bring them to you, and that's one of the parts of our product mix is we have economies of scale because, a cost of
SQL database brings you that. SQL database definitely brings you that. And yes, it is going to be more expensive to run your own SQL server than it is to use SQL database. I mean, and maybe I misunderstood your question, and then that's the more straightforward answer to your question. Does that help?
I think so.
If you look at Office 365, for example, I mean, based on the model, I think it would be very challenging for you to create your own internal infrastructure cheaper than what you can do with Office 365. But that's,
But people do. People do.
More cost effectively than Office 365?
I wouldn't say so, no.
That's
Yeah,
the point.
yeah. People do because they have some very specific reasons, a lot of which, I come from an enterprise IT background, a lot of which are cultural in nature.
Data security.
Data security, perception,
Mm-hmm.
demand for certain levels of control. That's, again, a good question that I think that maybe I'm not the best qualified to give you an in-depth answer to, unfortunately. So moving on to additional Azure features, we have this capability called table storage. And table storage is a NoSQL store whereby you have tables that are comprised of 4 key things. 3 obligatory columns, a partition key, a row key, which together provide the primary key for a particular data table and corresponding row, and a timestamp.
Is this an HDFS like?
It's not quite like HDFS. It's much more. It's much
your
simpler.
own architecture. Your own
Yeah,
okay.
it's our own architecture. It's very simple. It's very simple and it's very fast. The goal of it is that you want to be able to provide arbitrary key value storage with a single key and no additional indexing. That's one key difference from a lot of the additional other databases that are out there that are NoSQL, is that there's only one index, which is that primary key index.
So it's like HBase, basically.
It's kind of like HBase.
Yeah. Right?
Yeah. But again, the one thing to keep in mind whenever you're going to do anything with table storage is that you have one key.
You have one key per table or one key across all the tables?
One key per table, right? And you can make that key comprised of whatever you want. But the cool thing about table storage is that it's intended for scalability in such a way that the key that comprises the primary key for each table is of 2 parts. One is a partition key and the other is a row key. And the 2 together provide a primary key, a unique primary key. The partition key says, please keep these records co-located. It's like a clustered index, so to speak, except it's not unique unless you add the row key to it. And then the combination of the 2 allows the tables to scale horizontally.
And are you required to have the partition key?
Yes.
So you have to manually partition, know how to partition your data?
Well, so how your data is partitioned is actually up to the underlying system. So you just say, I want my table to have our partition key and a row key, and you give them values. And the way that the underlying data is partitioned is based on performance.
Okay,
So
but
the
it's a
service
clustering-
itself
I mean,
is...
if it's a clustering index effectively, where I get to say, look, all these I used together, so put them in the same partition, I would expect them to be co-located somehow, right?
You're going to get them co-located, but exactly how they're co-located is going to be based on actual system performance. And let me talk about blob storage too, and that might make a little bit more clear kind of what we're trying to achieve. So blob storage, in and of itself, is essentially a file system in the cloud where you're storing blobs, arbitrarily structured files in a file system. And the thing about the blob storage system is that it's really intelligent. It doesn't just store blobs in a generic, unintelligent way, but each blob is actually stored on 3 disks. And when you write to those blobs, the write goes to all 3 disks before the write is considered successful, right? And in addition to that, the way that the system works on top of blob storage is that it watches for hotspots in data activity, read and write activity, and it will additionally add spindles to your blobs so as to accelerate them without you actually doing anything. So for example, if you took a blob, let's say you took a big blob, and you slammed that thing over the span of an hour, you would see your IOPS go up over time because the system is actually analyzing the performance of your blob and it's accelerating it by additionally partitioning it. And that's totally transparent to you.
When you say additionally partitioning, you mean providing additional replicants?
Yeah, additional replicants, additional spindles with the same data on them.
So that raises a few questions. Like one is cost or how you charge for it, because if
we charge per gigabyte, per gigabyte per unit of time.
Per gigabyte of the blob or per gigabyte that's consumed?
Per gigabyte of the blob that you write. So let's say, for example, you write a 1 gigabyte blob. That's all you ever pay for. If under the hood that gets written to 5 gigabytes because of the performance, you're still paying for 1 gigabyte.
Okay, so you're just charging it then because presumably I have higher CPU costs, and then you charge for that effectively.
We just charge exactly for what you,
Okay.
the net consumer data as opposed to the net effective data. That would really be a bear trap if you got into a situation.
Well, that's probably why we were both asking.
So I mean, in some ways they're similar to Hadoop. Again, going back to examples where you store it in triplicate and
Right.
make
Right.
it available.
Right. And I don't have slides on this, but we also do have a service that's in preview right now, which is Hadoop on Azure. And we also have partners that are providing Hadoop services that have additional capabilities for doing, really, I guess, serving other markets. For example, the Hadoop service that you're going to get from Microsoft is going to be a platform. It's going to be something where it's targeted at developers and you build on top of it in a similar way where you would if you were to build out your own Hadoop clusters and such. We have partners, however, that are building out services that have a lot more fun stuff on top, a lot more features that make it easy to use, that make it easy to query, that make it easy to manage on top of the Hadoop service.
Okay. Yeah, because that's I guess another obvious question is, why create yet another Hadoop and yet another HBase when you can contribute to the existing ones and make them
And that's the
available?
thing. If you look at table storage and blob storage, they're not. They're really simple, and they intend to stay simpler and less feature rich than things like Hadoop and Cassandra. They're not direct competitors. They're maybe a tier of service, as you might think of it.
Okay, but it's attractive to be able to just say, look, I know how this works. If I use Azure, I don't have to rewrite my software. I don't have to redo everything I've done.
Use Hadoop. Go for it.
Well, are you gonna talk about the marketplace for a little bit at the end, maybe? And
In terms
some
of the
third
services,
parties?
yeah, sure, I can do that.
Also, on the very last bullet there, even talk at some point about, more about what it means to securely lock down permissions to blobs and also in general the security model.
Yeah, let's talk about that right now. So the way that the security model works for blobs is that every blob is contained in a container. And that container has essentially 3 levels of access to it, very coarse-grained access. Either public read access or public read and list access, meaning I can also discover the blobs that are in there, or private. Now, if you want to go and do something really useful from a security perspective, and when I say useful, I may be overstepping a little bit by saying that model is useful if you have publicly available content that you want to serve via, for example, a CDN or via just public resources. But if you want to do something more specific, we have this thing called shared access signatures. And shared access signatures allow us to provide specific types of read, write, delete, and list rights to specific blobs. So if you wanted to provide a very granular access to your file system, that's how you do it, is via shared access signatures. And essentially, shared access signatures materialize as extensions to URLs on the blobs, and they're time controlled, and they can be signed so that you can revoke them at any point in time, as opposed to unsigned, where since you don't have a signature, you wouldn't be able to revoke them. So that's the model.
Sorry, so you're saying that they are a component of the URL? Or
The
they're
shared
key
access
for-
signatures?
Yeah.
Yeah. So this, I sent a rather frustrated thread to some very senior people in the storage team saying, hey, why don't we have something like our, which I haven't spoken about, access control service for blobs, where we can have like NTFS style ACLs for the blobs. Well, without saying more than I can say out from NDA, that capability is in the works. When it's coming and exactly what it's going to look like, I can't tell you, but it's not there now. Shared access signatures are the solution.
But does that mean that anybody who knows the URL has a REST-like pointer directly into, with whatever privileges that are required, into contents of the blob?
If somebody went and created a shared access signature URL and then that got leaked, you're saying?
Or seen in transit or cached or 1,000 other things, yeah.
Yeah, absolutely. And that's why you'd want to do things like sign them so that you could revoke them. But yes, you have to distribute those over SSL, and you'd have to maintain the security of those shared access signatures.
I would advise you to remove the word securely from that slide, use something like privately or something.
I'll take that as feedback. Hence why I prefaced this with me saying that I've already sent an angry email to the powers that be. But I will tell you, that being said, there are folks using this very effectively, even beginning to do so in the healthcare space, which is a big deal. So
That raises a question in my mind.
yeah.
So as you have more of this infrastructure in the cloud, and you have described as secure capabilities that we were just talking about,
Yeah.
how can a developer, how can a customer figure out how secure their stuff really is? And so you're saying people are using this even in the healthcare field, and that may even mean it's HIPAA certified.
I was just
But
thinking, there's no way that's safe.
But that just means someone looked at it and didn't notice that you could crack it.
Yeah.
So how does the industry figure out how secure something is, where there's so many different pieces that no one can understand all of them?
So from a HIPAA compliance perspective, Microsoft is willing to sign business associate agreements to include the Blob Storage service.
Yeah, I'm not looking for compliance. I'm looking for it to really be secure. The compliance says someone signed that it's secure, so don't blame you if someone breaks in. I want someone not to be able to break in, which I know at the extreme is probably completely impossible.
More like
Well,
notification.
But how can you actually assess how hardened is it? Because you throw one of these in, and someone puts it in the email, well, they weren't supposed to do that. Well, people do the weren't supposed to's all the time.
Yep,
And it's even worse because despite something like this, I mean, there's a multi-level security problem. And this is sort of the platform security, but let's say you pick up a beef hook somewhere. They can see anything you can get at, right? So now they can come through your browser and access anything, and all bets are off.
Absolutely. I mean, this scares me to death, personally, and from an infrastructure standpoint. I mean,
so the best,
so someday some clever Chinese shuts everything down just because they can.
Well, apropos our earlier conversation about
Exactly.
why you
No,
think
absolutely.
they only have to be at the router, because the fact is that the URL goes in plain text through the entire internet. So anybody who can snoop anywhere on the internet can see what the credentials are. You know, the reason I can't get to the money in Steven's wallet is because I don't know his name. Oh, wait.
well, but so to be fair, the short answer is don't do that, right?
But Steven's a good question. I mean, how do you, suppose someone did, you know, and you don't want to build a security model where.
Yeah, I mean, don't do the things that put you at risk. Well, how the hell do I know I'm even being put at risk? I mean, I also think back, I mean, it's a different scope and a different perspective, to that person who had his Mac stuff wiped out because of odd interactions between the Apple login and the Amazon login and two other websites he had that allowed someone to wind through all of those.
Oh, yeah.
That's exactly the point where you've got this very complicated combination of stuff.
Well,
How do you
and-
know that you didn't just set your password to 000?
Well, and it's a little even worse than that, because what you're assuming is that the web app developers, because typically these are web apps on top of this, didn't do something that to them was unforeseen, but in retrospect is moronic. Like,
Well, I'm actually not assuming that. That's one of the reasons I'm worried. Having managed the
That's
Solaris
right.
development organization, I know what programmers do in security critical areas.
no, but I'm talking about people not that are in security critical areas and thinking about it and just make a wrong
Yeah, but the
choice.
ones who aren't in security critical areas aren't even going to think about it. It's only
Agreed,
worse.
right,
It's only
yeah.
worse.
Yes, okay.
I think the key is trust but verify, right? So we use an independent security firm, Accuvant, to do a comprehensive assessment of our cloud solutions, right? And we spent $25,000 and it took them 2 weeks. And they did a source code review too, right? So then they did all the hacker tests, you know, the cross-site scripting, SQL injection kinds of tests that you want. So you're right, you can't just trust any one of these vendors, and it's not just Microsoft.
Oh, no, absolutely.
let me also interject here by saying, part of the other story is that there are third parties like StoreSimple that provide solutions that have robustness beyond what the base platform offers, and they abstract the base platform away. And so, and I know that that's not the best answer.
Yeah, there's sort of two parts to the question. The broad and neutral one is the environment we're dealing with is incomprehensibly complicated. So how do people who genuinely want to deliver something that is robustly secure approach that? The more pointedly focused, higher security expert may be the part, isn't it a little worrisome when, if, in the case of you and Microsoft and Azure, you have a slide that says, can securely lock down, when it kind of really doesn't?
So, I think that, let me take a defensive position for a moment and say that if you look at the security capabilities that do exist, if you follow certain best practices to make sure that you don't make mistakes in the pipeline there, it is secure. But can you go and do things like you guys have all been saying to screw that up? Yes. And I think that that's true of virtually any security infrastructure that I can think of, including PKI and PGP.
I think this is a little different though. Some 22-year-old's gonna see that slide or the equivalent of it in a manual, and he's gonna put things in blobs, and someone's gonna write a HIPAA compliant system on top of it, and there's a huge hole. I'm gonna.
And
I
decades
consider-
later, 10 million people's worth of information will leak out through it.
Again,
I modify my advice to you from before based on Steve's analysis.
Yeah.
I think you should now change that bullet to completely insecurely locked.
I take the feedback seriously.
No,
I
really?
take the
I think it
feedback.
brings up a bigger philosophical question. I mean, you drive on the freeway, right? You know that you can get killed. Does it prevent you from driving? Can you avoid being killed by following the rules? Yes, CHP is out there. Let me finish. If you have enough money, buy a plane or helicopter that would ensure your safety. So at the end of the day, I mean, you choose it for convenience. This is the same thing here. It's
Not-
convenience
not
and it
quite.
opens you up.
Not quite, because someone else can do this to me.
Yes,
It's actually,
exactly.
it's actually exactly like a presentation I was on this weekend at Stanford on security in the law. And one of the people there was saying that the way he managed security is he controlled all of his digital information, and he basically squeezed it down to the absolute bare minimum and basically didn't let anything out. So being the kind of jerk I am, I said, how many people have noticed the digital information that is being created about you in this meeting without you actually having any control of it in that digital camera over there that has been taking pictures of you? And that, I mean, yes, you say, what do I care what the picture is? Well, you might be surprised what you care what the picture is about. But, so, someone creates information about me that I had no control of the creation, sticks it into one of these insecure blobs, and now I care. That feels very different to me than I chose to get on the freeway and I understand that it's dangerous.
No, but my point is, on the freeway, you still have 16-year-olds who can kill you because they don't know how to drive.
Yes.
And the equivalent to what Mike was saying, yes, there's CHP zooming by, catching those people from time to time. Yes, it's your responsibility to test your system with
Yeah,
one of those
but my
vendors.
case feels more like, and someone stuck me in a car against my will and put me on the freeway too.
In terms of your data being managed
Yeah,
by somebody else.
data being created, the data about me, potentially I view as private data about me, being created by someone else.
But,
Controlled by
and
someone else.
Joseph, let me expand on it, because I use exactly the driving analogy as I talk to our newborns about staying safe. There are things you can, driving is the perfect analogy, because there's no way to guarantee that you're safe. Right, because some moron's doing 130 miles an hour and slams into you and you're dead. But there are things that you can do, driving practices that will keep you safer or less safe. So it's sort of, you know, which end of that spectrum do you want to migrate towards? And there's no such thing as absolute safety. But you can affect a large part of your safety on the road by just choosing which end of that spectrum to be on. And the same is true for a lot of web security, right? If you click on every link that shows up in your email, you're on that, you know, driving very recklessly end of it, and you're going to die soon. You know, whereas if you practice some care, there's no guarantee that a very trusted link from a very trusted source doesn't still contain an XSRF or an XSS that gets you, but you're going to be less likely to get those.
No, that's precisely the point I was trying to make. That's precisely it. It's your responsibility to a certain extent, not responsibility of the system that gives you SaaS or PaaS service. It's you. I can choose a bigger vehicle, I can arm plate it, or I can choose again to buy a plane and not use a freeway. It's up to me.
It is, but if you're the user of a system that somebody else has designed and the system is built on something insecure, then you're sort of forced to be insecure, and you may not even know you're being insecure. Does that make sense? I think that's the point.
Yes,
Right,
that's
making.
exactly
but
the
there,
point.
I mean,
Exactly,
this is a
exactly
broader
correct.
challenge then, because even supposing this was perfectly secure, how do you know that the application in question didn't commit its own mistakes on top of that?
Oh,
right?
there,
Oh,
yes,
yes.
they're all
I mean,
aware of
but
that.
I guess the deeper argument simply is that if something is purporting to be secure, it isn't really, it would increase the probability of pseudo-secure applications built on top of it.
Well, this is not like the
Yes.
driving scenario. This is, I mean, to the extent it is, it's more like being stuck in an exploding Pinto or a self-crashing Prius, right? And, you know,
Who
yes,
was working
that-
on it?
but this is a little more like, because of that bullet there, and because I believe that Sean is, you know, repeating Microsoft's, you know, sort of intent, and they designed this. This is more like, he's telling us to all go out wandering around in the woods wearing deer suits during hunting season. I mean, they're actively, you know, the people who are actively looking.
Yeah, like
to
that
shoot-
cartoon Bummer of a Birthmark, if you've seen that one.
Far side.
Don't design security holes in as features.
Anyway, we probably beat up on
It's a
Sean
bullet.
enough.
Yeah.
It's a bullet. Look, so,
Okay, so-
the points that you guys making are fair, and there are holes that you could exploit. And there are also good ways to build systems that are pretty tight, locked down, if done properly. So if I might, can I recommend that we move on? And
Oh, yeah.
If you're clever, you will.
We can get you stuck on any slide.
Put a caveat and say use at your own risk.
No, you guys inspire me to want to have a slide that talks about blob storage in a lot deeper way, that talks about more advanced scenarios. So I find it useful conversation at the end of the day. So the next bit of technology I'd like to talk to you about is the Windows Azure Content Delivery Network. And essentially this is a geographically distributed caching mechanism for blobs. And this is intended for frequently asked blobs that you want to make highly available from many different geographic locations, much like any other CDN that you've probably heard of before. You can use it to expose content that's both in blob storage as well as in web roles that are static in nature.
What's the pricing model here? How do you guys accommodate peak usage?
It's based on egress. It's
Just that, and then
strictly
you
based on egress.
guarantee peak capacity, regardless of what it might be?
We don't guarantee a particular capacity level. We have a capacity level, and we have certain SLAs around how the service is going to behave. But if you're concerned about blowing out the CDN, I'd really like to talk to you in more depth about how you see that happening, because I guess that's a good question.
Well, any streaming event of any significance usually does that. So whenever that happens, people actually alternate between multiple CDNs, because often no single CDN can support this kind of traffic. So I'm just wondering, what do you do?
Do you support video streaming as well as just static data on your CDN?
So there's a whole other set of technologies called Azure Media Services that I didn't talk about here, which are in preview, that are intended to support a lot of that stuff. But yes, we do support both.
So both static video files and live real-time streaming.
There is live streaming available, but through Windows Azure Media Services.
And the media services includes authentication schemes for access to those CDN objects. Different ways of doing that.
You know, I'm not too familiar with it, unfortunately. I'm sorry, I'm not prepared to talk to that.
Well, are the blobs in this that are being cached
Yeah,
at these 25 locations, are they all read-only?
they are read-only.
Okay.
Yeah, they are read-only.
Because, I mean, I don't completely understand the usage model, but there's a cache consistency problem if they, because blobs, you're implying it's database content, not just.
You're implying a really vanilla scenario is you've got a website with lots of graphics, or lots of JavaScript files, or lots of CSS files, or static HTML files, or different sorts of things like that that you want to be able to distribute broadly across your web properties. And that's an excellent application for the CDN. But there are others.
In that example, does
Yeah.
the blob represent the entire, exactly the object that's delivered to a user, or is the blob something that you can look up inside using application software that's also fielded at CDN locations to be able to pull things out of the blob?
You're asking if the blob's atomic or has,
With respect to the end user's
What,
experience.
I think I understand your question, and let me try and answer it, and if I get it wrong, let me know. So what you do is you have your Blob Storage URL, and you essentially set up a CDN URL in front of that. And basically what happens is at each CDN node, depending on whichever one is closest to the user, the actual underlying blob gets looked up and pulled into a local cache at the CDN site and then served up. And so it's lazy caching.
So far, so good, but what's the client program that is requesting it of the CDN? It's not a web browser.
Yeah,
it could
it's
be
a web browser.
So if it's a browser, then the browser receives the entire blob. So if you've got a static web page or a graphic, a GIF or a JPEG or something, it's that thing that is the blob.
Yes.
Okay.
so it
Yes.
sounds like that they're trying to be the same as Akamai or
Akamai, right.
Limelight or.
So yeah, Akamai also. I see.
Yes.
Or S3 perhaps,
Pardon?
or Amazon's S3 service.
Yeah. Yeah.
One more question.
Sure.
Application acceleration, does it do it, or you only do basic CDN service?
So you can do application acceleration when you're talking about applying a CDN endpoint to a web application that has, for example, static HTML content or even dynamic HTML content like ASPX or PHP pages, but you're going to get a cached version of that. So there would be an application acceleration effect if that's the kind of thing that you're
Well,
talking
I'm
about.
referring to things that Akamai started doing when they basically take over the DNS resolution and they do it themselves in a much more efficient manner.
No, it's not that sophisticated at this point.
Right.
So the next piece of technology I want to talk to you about is the Windows Azure Access Control Service. And it's really a couple of key things. One is an identity broker, and the other is a claims broker. The idea being that you can say, Access Control Service, please authenticate this user for me using any one of the supported access control identity providers, and then provide back to me some set of claims from that identity provider that I can use in my application, and handle all of the round tripping and user interface for me for the user. And natively, in the most simple cases, you can set up Live ID, Yahoo ID, Google ID, and Facebook in terms of logging into web properties or other sorts of applications. But you can also set it up to talk to Active Directory Federation services so that you can integrate with on-premises Active Directory or LDAP implementations, so that you could allow a corporate user to log into an application that you've provided without having anything but the Access Control Service and Active Directory Federation services in between.
So if someone were completely in the cloud, could they be running Active Directory, have kind of a single sign to a whole globally distributed system?
That's the idea. Yeah, that's exactly the idea.
Sean, probably a stupid question. What if I don't have anything running in the cloud, but I'm interested in a simplified single sign-on?
Simplified single sign-on
Would
using
that
what identity
be-
providers? Using which identity providers?
A collection of applications that I control. So let's say something on premise, that my customer uses, and let's say the application that I'm selling my customer,
Uh-huh.
and they don't want to do on premises, so I would rather use something like that.
Yeah, absolutely, you can do that. And that's actually one thing that you'll see with like mobile applications or desktop applications or other sorts of things like that, is that the authentication is done via the access control service. And there's a little dance that gets played back and forth between the access control service and your application, but essentially what you get back is a document, let's say for example a simple web token document that contains a set of claims, and those claims, like your name identifier, maybe your email address, maybe other sorts of claims, would be provided back to you, and you could do with them what you pleased and use nothing else other than the access control service. The next piece of technology that I want to talk to you about is actually one of my favorites, and it's probably something that you've heard of in many different forms before, but it's called the Windows Azure Service Bus. There are two main components to it. In fact, let me back this up to the first main component, which is the Service Connect Relay. The idea behind the relay capability is that you would want to expose an endpoint that's behind a firewall to something that's not behind the firewall without having to open up IP endpoints inside your firewall. And basically what it does is it exposes a public URL that is essentially hooked up to by your on-premises service that wants to be called from the outside world. And when the outside endpoint is invoked, the call is relayed back down into the firewall, but because the channel was originally opened by the application that's inside the firewall, you can pierce that firewall boundary without opening it up. And today that's perhaps unfortunately a .NET technology, but I'm sure that in the future there will be expansions to that capability.
So how do you authorize and authenticate for that now? For example, can you use AD and Kerberos-based credentials, or how do you justify yourself as being able to use that URL and be able to make a connection?
So you do that by way of service identity. So the access control service that I talked about would be the primary mechanism for identifying yourself. So any of those identity providers that you would want to use, you would use with the access control service. So one thing that you'll find is that the Azure Service Bus and the access control service have the tightest integration, and the various things that you can do with them play best together. Next piece is the Windows Azure Service Bus. And the Windows Azure Service Bus, messaging subsystem. So the biggest and most important part of Windows Azure Service Bus is a core messaging publish and subscribe system like you would find in the likes of a BizTalk or Tivoli or even a simpler system like an MSMQ, but a publish and subscribe system. And there are two core artifacts that are the most important. One is the notion of a queue, and a queue is a cloud-based entity that you can write things into in a queued fashion and retrieve from them in a way that is very event-based in nature. So it's not a queue that you have to pull, it's a queue that you can wait on, and as soon as content shows up, you instantly are notified that you've got a piece of data that you're able to retrieve, and you are provided it at that moment. Topics, on the other hand, are like queues, except they are subscribable, multiply subscribable. So you can have a topic where you could have, let's say, 10 subscriptions. And each of those subscriptions get the opportunity to get access to a single message that comes into the topic. And from a performance perspective, because this is usually a very performance heavy kind of thing when you're doing lots of messaging, a queue can support about 3,000 messages per second, and a topic about 2,500 messages per second. And so if you want to scale beyond that, there are best practice architectures for doing even grander scale fan out and fan in kinds of infrastructure deployments. Once again, the security behind this is managed by the Windows Azure Access Control Service in terms of the operations that you can make against various data points. And we're just about out of time, so I want to go through these last couple of slides rather quickly. We have a couple of technologies that are on the networking front, one of which has been around for a while, called Windows Azure Connect. And Connect is a way to use an agent that lives on a remote machine and create machine-to-machine level connectivity between the cloud and an on-premises machine. And it's very easy to set up for a developer. It's not a way to bridge your network across premises. That is the next area that we're going to talk about, which is Windows Azure Networking.
Sean?
Yes?
Can that mechanism be used to move data between the boxes?
Yes.
Is that the primary use?
To move data between...
Premise, cloud, and back?
That's one mechanism. Another key mechanism for moving data between premises is to use Azure Data Sync, but that's thinking of relational data. But it could very well be used for that scenario. I think the most common use is that they want application level connectivity between two machines, but you certainly could use it for whatever you wanted.
Could that be a fat pipe? One of the problems that Amazon has is if you want to upload a terabyte or so, they say just send us a tape. Right?
So there are a couple of things coming in that space. One of them is called Direct Connect, and again, this is as far as anybody's concerned, not even in preview yet, which would allow you to create connectivity between Azure data center and a local data center at very high speeds. There are no performance advantages from a network perspective to this capability, so the short answer would be no, but there are things coming that will address those needs. So moving on to Windows Azure Networking. Windows Azure Networking is intended for network administrators, and it's a mechanism by which to actually connect networks between Azure and on-premises locations. So by way of a VPN device, as you can see noted, noted right at the apex of that arc right there. The idea is that the on-premises network would be given a subnet as well as a gateway, and you'd be able to communicate between these various locations at an IP level. So you wouldn't have to open up public application endpoints in order to achieve this. You would actually just use the regular kinds of application level, network level communications that you would want to use in a normal case. And so this is a really big deal when you think about making hybrid networks that cross premises. And then finally and briefly, Windows Azure Traffic Manager. Traffic Manager is a simple but powerful service for creating a programmable load balancer. So if you wanted to be able to distribute load between multiple geographic locations, you could do so by way of setting up your various deployments in the various Azure data centers, and then telling Traffic Manager that you want to unify those under a single address space, and then tell it what mechanism or what algorithm you want it to use to distribute the load between the various locations, whether that be round robin, whether that be lowest latency, or whether that be failover. So that's what Traffic Manager is.
Basis for a geographic disaster recovery?
Absolutely. And service level agreements, these are the service level agreements that you get with multiple role instances deployed. As I said, if you've got two, you've got the ability to have one taken down for service recovery or service healing or service upgrading. And if you've only got one, then you've got less of an SLA. And what's included, you can see the list there. I won't read those off. So we're past time.
So that 4.38 hours, it's very different if that's 4.38 hours of continuous downtime once a year, in which case you could be hosed.
Right.
Versus, a 15-second outage every 6 hours, which is probably almost undetectable in a lot of cases because a user would just hit reload and think, oh well, some network hiccup. What kind of a commitment do you make on that side of things?
On continuous uptime?
Well, how that's distributed, or is it just, as long as it's not more than this, we don't make any commitments?
We don't make any commitment. That's an annual SLA. But in practice, if you want to know what happens in real life, we don't get 4.3 hours of downtime. And if we do, there are credits that are issued directly back so that you're not paying for service that you did not get your uptime for.
Sean, there's an interesting definition of planned downtime. So if I know that there is a 6-hour window where I'm going to be down for 25 minutes, then effectively I'm screwed up for 6 hours, not for 25 minutes. How this jive with commitment of 99.995?
Yeah. So that's why we talk about multiple instances versus single instances. The way that Windows Azure works is that, and I wish I had a good slide, and I think I will include a good slide to talk about how this works in the future, is that, let's say, for example, you have 2 instances, and let's say this is instance 1 and instance 2. In that regard, what you can do is, and say what Windows Azure can do is say that, okay, I know that these 2 instances are serving the same content. So it's safe to take down one of them while knowing that the other one cannot be taken down simultaneously, because if I do, I'll affect an outage. And so all efforts are made to keep things that are intended to be redundant up in such a way that that redundancy is not sacrificed. Does that make sense?
Okay, so as long as I have multiple instances, and as long as I let you know that those multiple instances run the same service, so
Right.
there needs to be some kind of
And there is.
communication protocol here.
There is both on the platform as a service side as well as on the infrastructure as a service side. On the platform as a service side, it's the notion of a role, where a role, if it has multiple instances, automatically the system knows what to do about failure domains and upgrade domains, where it makes sure, for example, that if you've got 2 instances of a server, let's say in the simplest case, it's going to make sure that those 2 instances are on physically separate racks. Because, for example, you could have an entire rack go out. And if that entire rack goes out and you have both of your instances there, you're done. You're instantly done, right? And so Windows Azure is going to make sure that you have physically distributed deployments of your services across the data centers.
So that's a good point. What if you're on different racks but the same PDU?
So it's,
PDU goes out, you still lose both racks.
so what's going to happen is that if you're talking, so there are 2 vectors. one vector is the notion of a failure domain,
Mhm.
and then the other vector is the notion of an upgrade domain. So upgrade domains, or let's back up and say failure domains are defined as a rack. So there's no way that you're gonna have two instances of your service on the same rack.
Right, but failure domains aren't a rack, I mean, in reality.
In Azure, they are.
So you're saying no,
PDU spans more than one rack?
that would be wasteful in terms of PDUs.
That's what he's saying, it sounds like.
I would have trouble believing that, but.
So that's something that I can follow up on if I want to get you some good detail on that. I can take a note to provide some good detail on how exactly that works. I don't have good.
Multiple PDUs?
I don't have good.
Power distribution unit.
Yeah, exactly. One PDU is one rack.
No, multiple racks to a PDU. But different instances on different PDUs?
Right, but then you'd have to have the notion of a PDU as a failure domain.
Yeah.
Which is what we have.
Well, wait, I'm hearing him say there's multiple racks on a PDU.
No. There's so one power distribution unit is one rack. And if that's not the case, then they're distributed so that the failure domain notion is retained across whatever the physical distribution is.
Okay.
I think what I need to do
You can
is,
model it that way, but I think a rack as a failure domain is, that would be tough to buy, because either that or you're stranding a lot of PDU capacity, because a PDU can power scores of racks.
Yeah.
Yeah, I understand what you're saying. So I think this is a good opportunity for me to come back to you with something that exactly shows you how the breakdown goes, because I know that there's some great content from one of our data center architects named Mark Rusinovich. You may have heard of him, that talks about exactly how this works. And so I don't have that content ready to present now, but suffice it to say that if you're taking my word for it for just a minute, that it is designed in such a way that a failure domain protects you against power units going down simultaneously. So if you have one power unit go down, you're not going to have both of your instances go down.
Oh, no, that's clear if you have your failure domains defined properly. Yeah, I completely buy that.
Okay. Okay.
Steve, you have to assume that there is life outside of Google Data Center.
There is. Maybe crawling out of the sea, but.
I think you had something
He's
on,
complaining about terminology inconsistency.
I think you had something on the
Yeah,
slide.
I mean, it's something that I used to bump into all the time.
No, I get the problem.
Yeah.
It's a real thing.
Your final slide, you said something about not including VM container crashes, so maybe you could talk a little bit about what that means.
Let me open that back up.
If your own VM dies, you create your own virtual machine and it blows, it's your problem, right? Is that the way they think of it, as your virtual machine, not an instance of theirs that you're populating? I guess it's just, I'm just trying to
VM
understand that.
container
Maybe I don't
crashes.
understand what a VM container means.
Well, also, probably differs depending on whether it's IaaS or PaaS, right? I mean, if you're buying it at PaaS level, you don't own the container, you're a tenant within a database.
So like if you use like Amazon's AWS and you create your own AMI and you configure it in some bizarre way and it crashes because you configured it weirdly, that's not because it's your problem.
Right, the question is, what if you didn't configure?
But if you're
the
using one of
containers
the
there?
shared
So does
standard
VM
ones.
container crashes being excluded only count infrastructure as a service, not
Infrastructure
platform?
as a service,
Okay.
yeah.
So about 3 slides back, you said virtual networking, and tell me what this is right. So for example, you can establish a subnet that spans inside and outside your firewall. Is that one?
So generally what you would do is you would have, let's say, 3 subnets at a minimum. You'd have a subnet on-prem, you'd have a gateway subnet, and you'd have a subnet where your content is, where your VMs are on on Azure, and so you'd have communication at that level
Have to route through the intermediary subnet.
through the gateway subnet. Because gateway subnet is actually a gateway VPN device.
So I can't set up a subnet that spans inside and outside the firewall. I can't have a virtual network that spans.
It depends on how you cut up your subnets, right? Wouldn't it depend on how big your subnets are and how you slice them?
Well,
up?
no, it's an infrastructure implementation question, because, for example, if it's truly a networking subnet, on the one hand, it gives me enormous convenience, on the other hand, it's a real performance hit, because you've got, who's my AD domain controller while I'm sending broadcasts through the firewall to try to, find it in the middle of some infrastructure that's sitting in Brazil or something. So it would really affect performance, but also there'd be a lot of convenience if you could have
A single subnet.
a single subnet that would span inside and outside the firewall.
That's not the way that it's intended to be used.
Okay.
I think I've tried that myself when I've tried to set up a subnet that way, and I had all kinds of problems. I don't remember what my problems were, but then I went back to the infrastructure team and asked them what I was supposed to be doing, and they told me that I needed at least these 3 subnets in order to live well in the environment.
Okay.
And unfortunately, the infrastructure as a service and virtual networking stuff is still in preview for a little while. And so you can't just call up support and say, hey, what the heck is this? But if there's some specific scenarios that you're interested in enabling, that's something that I could take back and ask the product group.
Well, so the main thrust of what you described here with services was very data management and database heavy, right? But what about completely different applications that are exposed to user communities like Microsoft Exchange?
Okay.
And is that a place where you're thinking of going into that market? And I'm interested both from a technical standpoint and also from a business standpoint, because there are companies already that provide sort of
Hosted.
multi-tenant hosted exchange, and you'd be competing with some of your own customers. But on the other hand, nobody's better equipped to be running an entire Exchange stack or even an Exchange plus Bez stack than Microsoft.
Well, then we start to talk about Office 365. Are you familiar with Office
Not
365?
really, no.
Okay, so that's what Office 365 really is. And I'm not a super Office 365 expert, but that's...
It's pure SaaS.
Yeah, it's pure SaaS. Exactly.
And how does it relate to Azure? Is
It's
it run
hosted
that
on
infrastructure?
the same data centers. It's definitely all running from the same place is the main point.
And I was also thinking, you can imagine outsourcing substantially all the whole company's infrastructure.
Like
in Azure.
SharePoint.
So that, an existing model that's been around for half a dozen or more years is that you RDP back into some server that's using those terminal services, that's where your real computation is, so that you can have access to it remotely. But if you combine Azure with your AD and maybe other authentication models and the CDN capability, then suddenly it's kind of turning RDP inside out. I haven't quite modeled this in my head as we talk, but it seems like you could run your entire corporate infrastructure outside in Azure, and instead of remoting to, you're actually connecting to directly to the instance, because you're connecting directly to the first thing you touch is the Active Directory infrastructure from
Absolutely.
whatever you're on.
Absolutely.
So you don't have to run any more in-house Windows instances, except
That's
maybe
a
on your laptop.
big part of the vision. Absolutely.
There was a slide in the deck you sent me that's not included here, which is, I think, one of the last slides that show how you compare to, say, Amazon.
Oh, yeah. This is a slide that I'm not terribly well equipped to speak to, but this slide, what it talks about is, from Microsoft's perspective, the various competitive offerings in the cloud computing landscape, and what they are in terms of infrastructure, platform, or software as a service, and whether they tend to target larger or smaller offerings or companies. And so you can see that from an IaaS perspective, we've got Amazon and Rackspace in the IaaS space, and you've got them targeting the smaller customers. One of the things that you'll find is that from a recent Gartner report, Amazon has very poor penetration in the enterprise space, whereas if you look at VMware, they're targeting larger customers, and like Oracle, they have strong presence in the enterprise space.
So when you say VMware, you know, you don't mean Cloud Foundry, because that's.
I don't mean Cloud Foundry,
No,
yeah.
because that's kind of a joke, right?
VMware's actually putting together their own cloud.
But it's not Cloud Foundry, it's something else, right?
Yeah.
Yeah, because.
And, yeah.
When do they plan to launch that? Have you heard?
Just purchasing, yes.
Yeah, I just popped it up, Cloud Foundry. So that is VMware's entry into the platform as a service space.
Cloud Foundry doesn't have any concept of persistent storage.
I'm not an expert, I wish I were.
I don't know.
Hence why I kind of
Yeah.
skipped this slide.
It's
And Amazon Web Services obviously offering infrastructure as a service with a.
So I thought this is one of your better slides and you were going to skip it.
Yeah, I know you mentioned that. I know you mentioned that. And the main reason for that is because if I'm being honest, I'm somewhat new to Microsoft, and one of the areas where I haven't had a terrible amount of opportunity to get my chops really strong is on the competitive landscape, and so I'm working in that space. So. And then you've got obviously Salesforce, which is which owns Heroku, which is actually run on AWS, and then Google App Engine running in the PaaS
Salesforce
space.
has Force.com as well.
They have Force.com as well, and the thing about Force.com is that it's had limited penetration as a pure PaaS offering because it's perceived as being an extension to its CRM efforts. But there are a lot of people that would like to say that Force.com is a viable standalone PaaS platform.
There are a lot of apps developed.
Yes, there absolutely are. There's a perception problem, is my understanding from the research.
Do you know how well Heroku has been adopted? I guess you just said you don't have.
Heroku, so the reputation of Heroku is that Heroku's great until you really need it to work. In terms of low barrier to entry, ease of use, but then when you really want something stable, then Heroku starts to become a nightmare. In terms of that's anecdotal information from some of my colleagues that have deployed Heroku-based solutions, but
We use Heroku too. It literally went down the day we launched on Azure, and the worst timing ever. It was down for 30 minutes. So not reliable. But on the other side though,
anecdote number two.
wasn't Microsoft susceptible to the leap second?
Oh, yeah.
I mean, what was that about?
That was something that, and in fact, if you guys are interested, there's a whole article that breaks down exactly what happened. But basically, there was one line of code that did one piece of stupid math in terms of dates, adding date plus one in terms of certificate provisioning, and it turned into a cascading effect that started isolated, and then as time went on, when it affected a huge amount of services, that and that was a pretty bad day for Microsoft.
Was it a leap second issue or leap day?
It was a leap day issue. It was a day plus one issue.
Because there was a leap second issue.
There was a leap second, and there are a number.
Amazon, right? Because I think Amazon had a failure a few months ago related to, I thought it was a leap second issue.
Well, the only, a few months ago isn't ringing a bell, not relative to leap second, because I think all the leap seconds, the last two I'm familiar with, occurred at the turn of the year. But yeah, it's a problem because suddenly your data is different, or your time is different, and there are systems sensitive enough where that's a problem.
And they isolated the problem down to a single line of code, and they know who wrote the code too. So it was so very thoroughly analyzed, and there was an extensive blog article that was published that talks about everything that went wrong, what Microsoft did, kind of play by play exactly what went wrong on that fatal day. And the point of this slide is that the Microsoft offering really provides complete coverage across the IaaS, PaaS, and software as a service landscape. And that, my friends, is my presentation for you today.
So, you know, I think we were a tough audience, but my recommendation for next time
Yes.
is that we want to just have Raghu wear mirrored shades and a black leather jacket and stand behind you and be really intimidating and then be nice to you.
He's the karate kid.
You know, I didn't.
In Sean's defense, by the way, he spent the night in the hospital.
Just thinking about
Hey,
this.
I don't need excuses. Don't need excuses.
Yeah, Sean, you had to cover a large ground here, but I think
Yeah, thank you.
we enjoyed the.
Yeah, thank you. Yeah, that's very cool.
And it's
I
not
didn't
just-
feel like it was that rough.
We're a tough crowd on anyone, so.
Yeah.
So we'll circle back on those three issues, right?
Did you manage to take note? So we talked about the. We talked
The first
about
one was
the
on the security thing, which is really, we had to go back.
on the blob side of things. Yeah. What are people doing for really secure blob deployment
On
scenarios?
the SLA, you did answer.
And the PDU question.
And the third one was the PDU.
Yeah. Yeah.
Can we get a
Yeah.
copy of the deck? Well, you sent me one, did it change?
No,
Okay.
I sent you I used the exact deck that I sent you. Okay, folks, I hope this was useful. I hope this was at least informative.
Yeah.
Thanks very much.
Thank you.
Thank you.
Thank you.
Break, 10 minutes?
Thank you.
Oh,
Sorry,
sure.
sorry
Dinner?
guys, but I'm gonna have to leave.
Dinner?
This is my 32nd anniversary.
Wow.
Congratulations.
I believe it too, because it's anniversary, so.
As opposed to depicting that you have now been married for 30 seconds?
Wait, today's your vote?
Just the way you said it.
Second.
And is that a record?
No.
No, Elizabeth J. will surely beat that.
Several times, yeah.
He didn't say what kind of anniversary.
Yeah.
So before folks disappear too far, hand count for dinner. 1, 2,
Dave is going to.
3. Dave is 4.
Where are you going?
We don't know yet.
I might get in.
Okay, possibly 5.
You're very
Appreciate
welcome.
it.
Yep.
Thank you, and thank you all.
Thank you.
Thank you.
Who handles membership payments? Do you know if Informatica invoice got paid? I mean, the invoice from Informatica?
Yes, I have received.
You received it?
Yes.
Okay.
So stock price did not affect that.
No.